First step of scientific method involves observing something that might interest you. This is crucial if you're working on a science project, since you want to choose a topic that will keep your interest. This is where you came up with the idea for your science project. Your observation must be or can be on anything from plant movement to animal behavior, as long as it is something you want to learn more about. This is where you come up with the idea for a science project. Once you've made your observation, you must formulate a question about what you have observed. Your question should tell what it is that you're trying to discover or accomplish in your experiment. When stating your question, you should be as specific as possible. For example, if you are doing a project on plants, you may want to know plants interact with microbes. Your question may be, do plant species inhibit bacterial growth? Or watching an apple fall from a tree could be an observation. Seeing that fish only come to a particular part of the river in the early morning is an observation. Smelling garbage decomposing is another example of observation. Observations can use any of the five senses and including anything that can raise a question or start an investigation. Scientific observation can also define as any sensory experience about a natural phenomenon. Scientific observation can occur in a lab setting or a natural world.
The second step is formulation of hypothesis. But how can we formulate a hypothesis without knowing its meaning? Hypothesis is a key component of the scientific process. It is an educational guess anchored on published studies and literatures. It is also an idea that is suggested as an explanation for a natural event, a particular experience, or a specific condition that can be tested through definable experimentation. It states the purpose of your experiment, the variables used, and the predicted outcome of your experiment. Note that the hypothesis must be testable or measurable, and your hypothesis must be either support or falsified your experiment. First is we need to define our variables. In defining variables, you have to ask yourself the question, what do you want to test? For example, your variables are music and anxiety. Then you are curious if music has an effect on anxiety. Will music decrease anxiety or will music increase anxiety? The second step is study in-depth the variables. When we say in-depth, we have to dive deeper in the notion of knowledge. In our example given, you wanted to know if music reduces anxiety. Then you will find numbers of studies about it. An in-depth study, rigorous questions, and data of music reducing anxiety will confirm your hypothesis. And also, don't forget to specify your dependent and independent variable. Third step is specify the nature of relationship. Identify what relationship there exists between variables. What variables influences the other? What is the dependent and independent variable? In the case of example given, it said that music influences anxiety. If music plays a key role in reducing anxiety, then music is the independent variable, while anxiety is the dependent variable. The fourth step is to identify study population. You have to set your scope and limitation. If you wanted to know how music reduces anxiety in Philippines, then you have to specify and choose what part of the Philippines and what group. Not everyone has anxiety. Then you have to narrow it down. What part exactly of the Philippines do I want to study? What group of people? For example, you wanted to know if music reduces anxiety in Laguna, particularly the adolescents in 2nd District of Laguna. Then you have your sample size now. Last but not the least is you have to make sure your variables are testable. Testable variables can only be accepted or rejected. Nothing more, nothing less. In our example, anxiety is measurable. There are lots of standardized questionnaires out there about anxiety and music. It's also testable. We can test this through statistical treatment.
Step 2. Testing a hypothesis. Your experiment tests whether your predication is accurate and thus your hypothesis is supported or not. It is important for your experiment to be a fair test. You conduct a fair test by making sure that you change only one factor conditions the same. For a typical experiment, you should plan to repeat it at least 3 times. It is to make sure the consistency of the result. If you are doing something like growing plants, then you should do the experiment at least 3 times in a separate month. It is the same as doing the experiment 3 times. To conclude, always remember, repeating a friend's experiment is an important step to verify the results are consistent and not just an accident.
What does that word experimentation actually mean? Experimentation is the act or processes of trying out a new procedures, ideas, or activities. It is the steps in scientific method that helps us decide between two or more competing explanation or hypotheses. What's more of that is some researchers use experimentation to test existing theories or new hypotheses to support or disprove them. And why is experimentation is important in our life? Because it allows scientists to have a systematic steps to follow to answer question or statement about natural world and for us to get new insight and new knowledge. Besides, experimentation gathers important facts and observation to make more valid and reliable the statement we use in order to understand the world better. Experimentation is all about learning and gathering data. It is about answering your question and testing your assumption.
Drawing conclusion, the last and the final step of scientific method. Also, this is the most important part of the process. But let us first define what is to draw a conclusion mean. It says that to draw a conclusion means to make a judgment. How important drawing conclusion is? It needs to employ critical thinking. It also provides researchers with the opportunity to investigate the larger implication of their findings in depth and details. It is important because it should prove or disprove the hypothesis and answer the research question. In this step, this is the process of summing up what you have learned, observed, and experienced from an experiment. It provides a concise or brief summary of the result. The conclusion should be based solely in the result. In making a conclusion, it is critical. It determines the success or failure of the study. And remember, a failed experiment doesn't necessarily mean that it is a failure, but it can yield a valuable lesson.